Hello, so in this video we're going to be talking about slope-intercept form of a line. So as we learn more about lines, there's actually three equations of lines, and this is one of them. And this is actually, in my opinion, the most important one to graph with. Now remember, this is an equation that relates two variables. So you have your input value x and your output value y. So these two numbers here, m and b, these are going to be any real number. So this equation could look like y equals 5x plus 3, or y equals negative 2/3 x plus 2. So notice again, you input a value of x, and then you could do your calculations to calculate the paired value of y. And that's essentially what an equation does. But the beauty of this equation is that just by looking at it, the coefficient of this term, the number that is multiplying the x, this number just so happens to graphically represent the slope of a line. And graphically, it also just so happens that whatever number this is, the number that we're adding, the constant, the number that's by itself, that number graphically happens to be the y-intercept. So the beauty of this equation is just by looking at the equation, you will know what the slope of the line is and what the y-intercept of the line is. And with just those two pieces of information, you can actually graph the equation of your line. So for example, going to these examples, notice the slope is going to be 5 in this case. Notice it's the number multiplying the x. And the y-intercept is going to be 3. So that's the point on the y-axis. Taking a look at the other line, you can tell here that the slope is going to be negative 2/3, and the y-intercept is going to be 2. So just by looking at the equation of the line, you can identify these two things. So let's take a look at these examples and practice identifying the slope and the y-intercept. So notice for the first one, it's pretty straightforward. The slope is 3. It's the number that is multiplying the x. Now, if you recall from the original equation, notice that the y-intercept is the number that's being added to the x term. But notice here instead we have a subtraction. Well, remember, subtraction really is just adding a negative. So in this case here, it just so happens that the y-intercept will be negative 4. Let's go to the next one. Now, a mistake I hear a lot of people say is they say, oh, the slope is x. No. The slope is the coefficient of this term, or again, the number that's multiplying the variable. So we see just a variable by itself, but remember, there is technically always an invisible one multiplying a variable if you don't see a number there. So technically, in this case, the slope is 1, and the y-intercept is 2. The next one is a little tricky because at first glance you might wonder, oh, wait a second, this doesn't look like slope-intercept form. But remember, you can technically flip terms in an expression. So if you were to flip these, you could visualize this as being negative 1/4 x plus 7. And now it makes it a lot more clear what the slope and the y-intercept are. So the slope in this case is negative 1/4, and the y-intercept will be 7. And finally, the last case here, The slope is very easy. It's the number that's multiplying the x, which is 2 in this case. But the y-intercept, you might be wondering, but where's that number that we're adding or subtracting? Well, this is another important rule. If you don't see a number, that means technically that you're adding by 0. So you don't really have to show an addition by 0, but that doesn't mean it's not there. So technically the y-intercept here would be 0. So pause this video and try to identify the slope and y-intercept of the following linear equations in slope-intercept form. Once you have completed it, unpause this video so that you may see the solutions. And there you have it. Now, as I mentioned earlier, there are a few other equations of lines that you might run into. But slope-intercept form has its benefits, particularly if you want to graph the line. See, the problem with standard form is that A, B, and C don't really tell us anything about the graph, as opposed to the equation in slope-intercept form, where all you have to do is look at the equation and you know exactly what the slope and y-intercept are. So you can already have an idea in your head about what the graph will look like. So all you really have to do is solve for y. It's a very simple technique. So first of all, if a linear equation is given in standard form, all you have to do is first move the x term to the other side of the equation. So in this case, we want to move the 6x over to the other side. So we'll subtract 6x. That allows us to cancel the 6x on the left. But of course, to balance the equation, we have to subtract 6x on the right side. So now we're left with 2y equals 4 minus 6x. Notice I can't combine those numbers, 4 and 6x, because they're not like terms. The final step to solving for y is we need to remove the multiple of 2. So to remove that multiplication, we divide by 2. But of course, if we divide the left side by 2, we have to divide the right side by 2. And remember that division is distributive, so we have to actually divide both the 4 and the 6x by 2. And this gives us y equals 2 minus 3x. If this bothers you, as we stated earlier, you can always flip the equation, or you could say y is equal to minus 3x plus 2. These are both the same equation. So now you can see that the slope is -3 and the y-intercept is 2, which is something that you couldn't tell by looking at the original equation in standard form. So let's take a look at 2 more examples here. So these are both in standard form. Now, the first one may look a little off, but remember, you can always flip those if it really bothers you. But the goal is to solve for y. So we want to isolate the y. Any values and terms that are not y, you need to move to the other side. So first of all, we need to move the term with the x to the other side because we don't want x on the same side as y. So to remove that subtraction by 2x, we can add by 2x because that will cancel the subtraction. But we need to add 2x on the right side as well. So as you see, the 9 and 2x will not combine because they're not like terms, so you can't add them together. And finally, we could remove this multiplication by 3 by dividing. And as we said before, we need to distribute that division. So 9 divided by 3 is 3. And 2 divided by 3, we just leave that as 2 divided by 3x. You could write it as a decimal, but most of the time it's best to leave slope as a fraction. And once again, you can also flip the order and say 2/3 x plus 3. It won't make a difference at the end. They're the same exact equation. For the next one here, all we have to do is solve for y. So any terms that don't have y need to move to the other side. Therefore, we need to move that 10x first. So by subtracting 10x, it allows us to cancel that out. So notice that this subtraction is attached to the 2. You can't remove that. So this remains as negative 2y equals 7 minus 10x. And now we could remove this multiplication by dividing by negative 2. Since we were multiplying by negative 2, we divide by negative 2. So, as before, we distribute the division. So 7 divided by negative 2 just stays negative 7 divided by 2. And negative 10x divided by negative 2 is plus 5x. Or you can feel free to flip the terms and say 5x minus 7 over 2. Both are correct. It doesn't matter which one you give. Both are the same equation. Okay, so here are two equations in standard form. So go ahead and solve for y so that these equations can be rewritten in slope-intercept form. Pause this video, attempt to solve, and once you have completed, unpause to see the answers. And there you have it. These are the answers in slope-intercept form. Now let's say that we're given the graph of a line and we want to write the equation of that line. Well, this is another reason why slope-intercept form is so useful. By looking at the graph, if you can identify the y-intercept and you can identify the slope, you will know exactly how to write the equation of the line in slope-intercept form. So by looking at the graph of this line, we can see that it has a y-intercept of 1. So immediately you know that the y-intercept, or b, is 1. Now, to find the slope, you really just have to look for the two easiest points that you could think of. So let's say, for example, this point and this point. And the beauty is it actually doesn't matter what 2 points you pick, the slope is always going to be the same. So we could say this point to this point, or so on and so forth. So all you have to do here is, remember, slope is rise over run. So to get from this point to this point, we're going to rise 2 units. So we're going to go up 2, and we're going to run 1 unit. So we can say that the slope is rise 2, run 1, which simplifies to just 2. So because we know the slope and y-intercept, refreshing what the equation of the line looks like, y equals mx plus b, we can now input those known values. So the equation of this line in slope-intercept form would be y equals 2x plus 1. And that's the equation of this line. Now let's take a look at this line. So by looking at this, immediately we can see that the y-intercept is 2. Now, picking any 2 points we want, I guess let's get this point and this point. First of all, notice the slope is decreasing. It's going down as we move to the right. So that tells us the slope is going to be negative. And it makes sense because we're going to have to go down 1 unit and to the right, or we're going to run 3 units. So we now know that the slope is down 1, right 3. So the slope is negative 1/3. So now that we know the slope and the y-intercept, the equation of this line would be y is equal to negative 1/3 x plus 2. Let's do this last one together. So by looking at this line, we can see that the y-intercept is -3. And now picking any 2 points we want, so I'm going to guess this point. And really, you just have to look for the easiest point, the one that's like obviously has easy coordinates. This point here, has the coordinate 2, 2. So to get from this point to this point, I'm going to have to rise 1, 2, 3, 4, 5, rise 5 units, and run 2 units. So my slope is rise 5, run 2. So 5/2. Just a note, if you ever get a fraction that can be simplified, you should. So just as a side note, if you ever find a slope of, for example, 10/4, that could be simplified to 5/2. So it's up to you, but just make sure whenever you give a fraction to always give it in its most simplified form. So now that we know the slope and the y-intercept, the equation of this line would be y equals 5/2 minus 3. You could say plus -3, but remember, adding a negative is just subtraction. So that is the equation of the line. So here we have a graph of a line. So go ahead, pause this video, and see if you could determine the slope and the y-intercept so that you can write the equation of this line in slope-intercept form. When you are ready, you may unpause this video to find the answer. And the answer is y equals -3/4 x plus 2. Again, if you got a different slope, ask yourself if simplifying it gives you the same slope of -3/4. Remember, you could pick any 2 points you want on this line that are easy to identify, and you will always get a slope of -3/4 once simplified. The last important thing we need to know how to do is, now that we've learned how to interpret the equation of a line in slope-intercept form, and we also know how to write the equation of a line in slope-intercept form, can we draw the graph of a line in slope-intercept form if we're given the equation? So it's actually very simple. It's actually like what we just did before. You're just going in reverse now. So assume I give you the equation of the line, y equals 1/2 x minus 4. So as we practiced before, we know that the slope is 1/2 and the y-intercept is -4. So the first step is you're going to want to draw out your y-intercept. So that's a point that we know for sure will exist on this graph. So notice how I put a point on the y-axis at -4. That is your y-intercept. We know that that's the point that the line will cross through on the y-axis. So the slope just tells us basically how much do we have to rise and how much do we have to run to get from any point on the line to the next point on the line. So this is telling us we need to rise 1 and run 2. So since we know the point on the y-axis at -4, to get to the next point, we go up 1 and we go right 2. So this is our next point. Now, once you have 2 points on a line, we just connect them. If you want to for fun, you can keep plotting more points by going up 1, right 2. As many as you want, really, it doesn't make a difference. You can also go backwards and go down left, down 1, left 2 if you want. The more points, the better, but really with 2 points, that's enough information to sketch the graph of your line. And there you go. You really only need 2 points, but if you want to, you could plot more points. Just keep following the rise over run pattern. So notice here for this line, the slope is 3 and the y-intercept is 2. Now, it's best practice to always write slope as a fraction because you want to be able to interpret it as rise over run. So if you ever just have a whole number, you can always just put it over 1, and there you have it as a fraction. So immediately we know that the y-intercept is 2. So all we need to do to find any other point is just follow the slope. So we're going to rise 3, we're going to run 1. So we go 1, 2, 3 up, and we run 1. So that takes us to this point. Notice we rise 3, run 1. If you want, you could plot more points, but really just 2 points is enough to sketch your line. And you just connect the 2 points with a line. Let's do this last one together. So notice here, it looks a little confusing, but don't forget you can always flip these terms if you want to. So the slope is going to be negative 1/4, which it's already a fraction, so we know the rise and the run. And the y-intercept in this case will be 5. So we know the y-intercept is 5, so immediately we can plot that y-intercept right there. Now keep in mind, the slope is negative, so that means as we move to the right, we have to go down. So this means we're going to rise -1 and run 4. So we're going to now go down 1 and to the right by 4. So notice that slope is negative. We're going down. The line is decreasing. You could technically think of this in reverse too. You could think of it as going up 1 and to the left 4, which would put you right here. But notice if you connect all those points, it's going to get you the same exact line. So we get a line that looks like this. And there you have it. So that's why this equation in slope-intercept form is the superior equation for graphing. So pause this video and see if you can graph these 2 lines. Once you have finished, unpause this video so that you can see the correct lines. And there you have it. There are your 2 lines. The one in blue is line A, and the one in red is line B. So that wraps up this video on the basics of lines in slope-intercept forms. In the next video, we will talk about real-world applications and why understanding the equation of a line in slope-intercept form is so important in real-world context. Thank you. Bye.